in my channel, you can see some edited clip about 3x3 sliding number puzzle implemented in Python. And you can move arrow keys up, right, down, left, and you make it to the original place of each numbers. But I'm gonna extend it to n by n. Anyway, there are some mathematics for these puzzles. I was kind of interested in this because I never have implemented the solution for something like this. But I read the Wikipedia about the n puzzle, how to find a solution. There are some published in maybe 200 years ago, so something like that. And there is some paper related to this published in 1974 about 15 puzzle solving using bipartite kind of graph. So it needs kind of graphical representation of information. And there are some mathematics, group theory, which is I don't know. I'm not quite interested about the history of this puzzle. I'm just interested in solving this puzzle. So anyway, let's start with the code I have implemented so far. So in my GitHub, the calendar repository, so git clone, this one, paste. Okay, let's code. And this bonus, don't need it. Oh, oops, I never, okay, uploaded the image piece. Okay, anyway, I'm gonna just delete everything, and I'm gonna download some beautiful image for this puzzle. Snow, go. Yeah, this is good. Free download. And I also need some black image. Let's just save image, black. Okay. And for the entire puzzle images, I'm gonna change the name as IMG and scale down to 300 by 300 and pick JPG. Okay. Serve images, and I don't need that. And for I in range 3, there is some raw images. It's just empty. Then for J in range 3, and sub image is equal to img.serve issues. Serve surface, it has 100 pixel times J. 100 pixel times I is the position, and it's because it's rect, needs some size, right? And size should be 100. I need to append this as image into raw images, the as images. Okay, then after escaping the inner loop, I want to append the raw images into pieces. Okay, raw images. Good. And then that's all. And the last pieces should be black image. So I need to, this is not image, this is empty, but I cannot show the last pieces without this. So I need to, instead of original sub image 2,2, I need to swap the image by the black image. I want to call it piece 0 because I just used as an empty cell for this image. Then just copy that. Black.jpeg. No, it's jpg. Black.jpeg. Okay. And then also rescale by 100 by 100. 100, 100. Because it's 3 by 3 until now. Last pieces element is 2, 2. It's just the black image. Everything done? Let's check. Python. Numbers. Oops, there's no directory pick dot no img in the current folder. Try this again. No such file. No, not pick. It's black. Then okay. Outside surface area. No, it needs to be tuple because it is one rect object. Try this again. It should be piece 0. This also piece 0. Yeah, it finally shows something. So this goal should be definitely left side. And this, yeah, I cleared. Stupid. So as you see, the solving just 8 puzzles is seemingly difficult for someone like me. So I need to make computer algorithm solve this. That is my aim. And also I need to handle this for n by n. Copy for n by n cases. So copy and paste somewhere. I'm gonna make this handle the cases larger than 3 by 3. So rename it puzzle. So let's say n puzzle. Yeah. And then I don't need this anymore. I want to collect a number of width and number of lengths or height for this puzzle. Let me say just m is equal to 3, n is equal to 3. Also want to collect the number of shuffles. Num shuffles is equal to, maybe it initially is 0 and also num list is here, and that's all. And this, so basically I want to, there's no argument for main and file, but I'm gonna collect the parameter from the terminal. So sys.argb, it collects argument attached to the Python file. So I need to exclude the file itself. So if there is, this is the command for executing the game, but I want to specify 4 by 4 shuffling 10 times, something like that. Definitely this main function should collect options from this. So this is just 4, 4, 10, right? And it could be a list containing 3 elements, 4, 4, 10. And then I want to, from options collected from the terminal, I'd like to, in this main function, the size of a puzzle should be defined outside the main loop. So that's why I just declared the variables there. So I want to use global m, n, and number of shuffles and num list. Okay, so it should be string, so I need to convert it into integer, and option and 0. This should be, and n is options 1, and number of shuffles, definitely options 2. Okay, I want to specify the cell size as a variable, so 100, and instead of doing just displaying every pieces without a border, I want to have some border between each can I say tile or border. Tile is better, right? Each tile. So I want to make a tile smaller than the original 100 pixel. It's a little bit less than 100. It should be better. So I want to specify the cell size too. Maybe it's something like integer cell size times 0.9. So I want to make it tight. So maybe I want to, not 9. So I want to copy here. This cell size 2. Right. Okay. What about 9 times? That's better because I want to make it or every number even. That's a little bit less. If the cell size is 100 and 96, so it's better. And then the Pygame has some entire width and height for them for displaying the windows. Definitely it is something like that, and it's W4, the displaying window width, cell size definitely times M. This M for width, and H is cell size times N. Just rename IIJJ. Blank is empty cell. Blank, so let me say just II is 0 and JJ is 0, and then I should replace every II in this file to blank I again, and jj with blank j. Okay, renaming done. And also initializing this list should be not here in the main function. Okay, and so what about the pygame init? Also in the move completely in the main function. Okay, and these not anymore 300 by 300. It should be w comma h. 50 is enough. Okay, already know everything. So, and then okay, it's not anymore. And this for n, this is m now, and this is also m. And this is shuffling, right? And so I want to make it a little convenient for this. So to shuffle, after initialization, I shuffle the puzzle one time, and after clearing the puzzle, and I need to reshuffle it. So there is a repetition of the code. So I want to make it as a function. This goes into separate function. I want to define a shuffle puzzle, let's say just my list, number of times, and paste it. So number of times goes here, and so I need blank ij inside the function. Let's say just number of times, range int, and this is a repetition. Every time I need to first check search for the blank ij index one time. Not every time in the inner if or ellipse statement. So it's repetition. So I just remove everywhere, and I need only once before checking the randomly generated number represents somewhere, some direction. So one time. So here. And then, and also, sometimes it do not move, because if I just say 100 times shuffle, it does not always guarantee that you move the tile 100 times. Because if this is the case, like if you press upward key, and then this is an end of the line, the blank piece is most bottom, and you cannot move upward, right? Even if you try it, it ignores the movement. So you guarantee that the entire movement should be add up to 100. So I need to check that. So idx, I need to define another variable for counting the real movement only. So I just want to count that. So while idx is less than num times, do here, not this anymore, because it's automatically just increase number every iteration, so I don't need that. And generate a random number, and this thing is also wasteful, because even if you found the blank index, you still go on. So I need to break somewhere here. If I found the empty cell, empty tile, and let's say I make using some variable, I need to make it found and break, and if found is true, then break the outer loop, and then that's all. And a found variable should be somewhere in, maybe here, found is false. Okay, and if it's not anymore, because we handling general cases, so it should be, it is for width, so not 2 is n minus 1. Okay, and this for moving left and right cases, and this is not 2, is m minus 1. So I don't need this one, right? Image cases. Okay, I don't need this. Delete it. Also this one. So random solver. Do I need? No, I don't. And this piece should be also there. I'm gonna use shuffles piece 0. Let's do have it here. Global shuffles. Yes. The num list pieces and also piece 0. WH should be. Let's just done. Reshuffle 100 times. I don't need it. Delete it. And before the while loop, shuffle puzzle, maybe num list, number of shuffle times. Then go for 10. No, it's not M, it's N. This also N, M. This is N minus 1, M minus 1. Should be. Am I right? It's N puzzle. It's not 3, it's M. What's that? It's not N minus 1, M minus 1. It's not IJ. Don't use variables. WH. And this thing. No. Just copy. Here. Go down. Before that, you need to change it using variable. It should be M times, it is X and Y. So M times cell size. It is N times the cell size. And piece 0 will be cell size. Okay. And cell size. Where's IMG? I'm gonna use this IMG and piece 0. IMG. I need IMG. Cell size. Try this again. Not this one. It's N by M. Because the IDX still 0, so it is stuck in infinite loop. Random movement is made, then I need to increase the IDX value by 1 so after making a move. So if it is not N minus 1, it can be movable. So IDX should be increased by 1, and also for this case, and for this case. And do it again. Okay, here not N, M. It should be N, M, and everything M. And N, M, N, M. This also, we don't need it because it's a repetition. This is not, J is not equal to 2, it's M minus 1. This is for N minus 1. This goes outside the event key. If we found out position of the blank cells, let's mark with 2. Okay, we do some variable as a true, then it needs to be somewhere here. So let's make it found is false and break. And after that, if found is true, then break out the loop completely. It's N minus or N minus 1. Yeah, working quite well. Boom. And clear. But since this is not 3 by 3, I need to check count is equal to 0 for y in range n, for x in range m, loop through the 2 loops. If num least, instead of this one, ij is equal to m times y plus x plus 1. Increase the count variable by 1. And after that, if count is equal to n times m, I need to subtract by 1. But let's just say use this, and then instead of fill 0 for the empty cell, I want to make last number. It's more natural, right? I want to fill this m times n. Because 4 by 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, not 0. This time 16. 16. I'm gonna use 16. This, we don't need this anymore. And if this is m times n, just change it. And also I want to change this. Okay. Try this again. Display mode, it should be not here. Surface, it only used it in main module, so I just want to be here. This tile is too complicated, so I want easy configuration. So cleared, yeah. I need to shuffle again. So I want to reshuffle again. So if the clear the case, I need to reshuffle that. And time 2, reshuffle again, clear false. So then here, boom. And what about this? Cleared, and 2 seconds later, and different game start again. Right? That is my main purpose. So if I say just like not 4x4, I can make 6 times 4. Yeah, not harder, but definitely it works. Or if I just make a 10 by 6 and 50 shuffle, and still working, right? This. So I've done that, but if the piece is getting more complicated and solving this puzzle is really, really difficult. Anyway, I'm gonna automate it. So I'm gonna implement a random solver for this puzzle. So rename puzzle solver. And I don't need key movement, right? And I delete it. I don't use this Pygame event get keyboard signal. I don't need it. And while running, I'm just displaying the solution path. 1 adder, 1 second. So we don't need it. Key down or something like that. So we don't need it, and we only need to quit reshuffling. Then here I need to find a solution. Maybe I can still have that one. Puzzle solver, it's precisely it's random, right? Random solver. RND solver. Not, oops, I need this again. Copy that. And here, event get. Okay. So it's still same. Python and RND 44100. The same, right? But instead of moving the tiles by arrow, randomly choose. So there is some movement type here using just random movement, not just event key, not key down. So move type here. Random, delete it, and every time, and I select some move type here, move type number. It's equal to this kind of thing. It is just a random solution, so it's very, very simple. It's a right, and it was right, it was left, it's up. Here, okay, not here. It's the big. We don't need it, right? So if, let's say, yes, right, and I need to do these things. It needs to be updated. Surface. No, was there? It was there. There was clock. FPS clock already defined. So I tick rate should be maybe 100 times per. If not cleared, then that's okay. Go. Yeah. Because it's randomly make a solution. Oh, by the way, let's just speed up. Maybe anyway, tick rate frame per second should be higher. Go again. Okay. Let's see. Even if just 4x4 puzzle, this brute force solution is not working. So if I just slightly decrease the dimension by, let's say 2 by 2 or 2 by 3, and then its solution quickly found, right? It's really bad, right? And even if it's just 3 by 3, it takes time. So I need more clever technique. I need to really find the path, the shortest path, because this randomized movement is still going on. And after you find out the solution, the trace is really long. It's not optimal. So I just pause here. I want to copy the file, make another file, so copy and paste, and rename it so BFS solver. And previous file rename as just RND solver, because BFS is just like from Wikipedia. It's a kind of algorithm for searching graph data structures. So if there is a one node, the root node or the higher order node, and you go down and you have two children, and you check older siblings and you go down, you just search every node in parallel. If the length is the same, then go deeper, and it guarantees the optimal solution while taking rather long. But there are some different solution is depth first search, DFS, and it instead explores the node branch as far as possible before being forced to backtrack and expand other nodes. But BFS, its guarantees is its solution, and the BFS does not need the stack, but it needs some queue. First in, first out. Such node comes in, and then when you want to search that node, and you need to first search the first comma. So first in, first out. And then if there is a new node coming in, you attach at the end of the queue. So you keep updated whenever you find a new node to search for. So I'm gonna make BFS using queue. So we need some new data structure called queue. So QUE is inner libraries in the Python. When you install the Python interpreter, it's definitely in there. And queue only import queue module. There is just ordinary queue like this queue and priority queue and some etc. Not many, just several things. So I just imported in the main function. Before that, I need to make queue. So let's say queue name is my queue. From queue generator. In the main function, before this, I shuffle the puzzle and then find the solution using BFS. Okay, and then so I need, this is kind of so BFS is using queue, and their solution it's something, because I'm gonna make the left, right, down, up movement as a alphabetical character. I'm gonna attach one by one movement to the solution string. And also I need to attach the first solution to the queue. Solution attached, which is empty path, and then check while I didn't make any solution, but why not? It's solved if I made ready about algorithm whether path is complete or not. Then repeat the path binding. So another solution I attached from the queue, dequeue it means dequeue element from the queue, and which is get, so not one element. So there is alphabetical character. So for J in range, U or up or down or left or right 4 times attach different solution, possible solution. Next pass is made and is solution plus J. And so if this next pass is valid pass, then I put this new pass into the queue, and then I check whether this pass is solution or not, and until we found a solution. And as soon as we found the solution, we escape the while loop, and then we display the solution visualized. So then my queue dot put next pass. Okay, that's all. And so let's try to put some argument here. What kind of parameter should be there? It should be num list. By the way, num list should be untouched. So I need to copy, because every time you make a move, and if you check whether the solution is reached the complete solution, you need to check one element by one element between the original list and the list modified by the solution. Let's make a copied solution, copied num list and solution. So num list is not touched. At some point we need to copy. Somewhere I need to import copy dot did copy. I did copy it. And also whenever I found out a new path, I need to and I need to whether the new path is valid from the num list. Num list should be original, so I need to update the copy num list as original num list. Of course, it hasn't been defined yet. After finding out the solution, print out the solution string solution. Then copy num list should just do not display anything yet. And I need to define 2 functions. Is valid, def is valid, pass, and then so there is some list input. So input list the moves, okay, because moves is solution. And there also need to inner variable length ij, which is very similar. And then so for say every move in moves, it is string, right? LIDU, something like that. And copy from the shuffle, very similar. Just copy that. Okay, and copy. And m as num list is input list. So input list is m times n and blank ij. It is assigned respectively and found out. Okay, say every move, so it needs to be initialized by as false, and then make it false. And not move type is move. Change this move. Okay, next. Okay, if you should check several times movement is not valid, you need to return false. Okay, when you try to move upward, then not met the condition, then else immediately you return false. Same for other direction. So we don't count up idx, and let's paste. Okay, this and that. And if there is no return false there, finally here up, down, and after escaping the for loop completely, then we return true. Okay. And there we go. Function was, this is for if the movement is valid or not. And this is for the puzzle is completely solved. So def and it's solved. It's solved. Okay. There is some argument there. It needs as input list. Of course, list should be original or shuffle patterns needs to be maintained, and also has a move. It's pretty similar to the valid, but less load. I just copy this one and paste it. This time, because this one also need to deep copy the element in the whole list. Valid, then I need to clean up. Go to definition again. I need to deep copy the num list. From the num list, I copy that deep copy num list. Reinitialize input list. Input list is this argument there. Okay, I need to change that. And this one is the same. And also this one is the relatively similar. If this path is valid, then you put the possible solution into the queue. So you don't need to check whether this solution is valid or not anymore. So you don't need this one. It's just wasteful. So you make a move, and this original list is changed. And then after completing the change, you check whether each element from the original list and individual element from the copied list, if they are same element, then you just count out. And if this count is m times n, then you completely solve the puzzle. So, it's hard to explain, but let's make another smaller function for counting the number of pieces in place. So num piece, let's say just tiles, number of tiles in place. You just count up. So input list, from input list, you just count up, and the count is 0. I just use this thing, right? Copy that all the way up to there and here. So input list. Okay, let's count. We don't need it. Then just return count. In the isSolve function, you call number of tiles in place from, it should be input list. This should be input list. Right, input list. Okay, and then input list. If the count is equal to m times n, then you completely solve the solution. So you just print out. You don't need to print out the solution. Just return true, and then otherwise return false. Okay, that's all. Let's check. It's not num list. It's also input list. So everywhere. This has to, okay. Here, we should put the pause there. Here, just in. Okay, this we don't need. You find out, but copy num list. No, we haven't found solution. There is a solution, but it's wrong. 7, 8, 9. It should be. And after that, just here. And then I use this, and we don't use this. Try this again. Yeah, it's solved. So it's 4, 1, 3, 2, 6, 8, 9, 7, 5, and it's now it's sorted. So then I'm gonna display the solution here. So not so the show the solution. Display the solution. Okay, I just don't want to display this anymore. And then find the solution and done. So take 1 second per tile is enough, I think. And then let's do, there is a solution, okay? And the solution has a string, and so it only goes fine one movement by one movement. So while running, it's not clear. I need idx. X initializes 0. Then we don't need this one, right? If x is 0, then if idx is less than length of solution, move, not move types, move equal to solution IDX. For that non-num list, we don't need move type anymore. Move num should be changed as move. Boom, boom, boom. And go down to solution. Where is the solution? Solution is there. Undefined. This is solution string and IDX and move. Okay, move is all then. Okay, and let's check. And then after that, this move is made. IDX increased by 1. Okay, we don't need to that. We only need solution. It is solved and it's valid. It's just for simulation, so we don't need to just modify the images. So here, we don't need that. We shouldn't actually. So here, and for its solved function, same. We shouldn't make any modification of images. We just delete everything. List before I need it. After list after 6, 8. No. That's no problem. Non-move. It is num list. I J. It's not move. And let's say S15 shuffle. And it finds out solution. Okay, try out some 30 times shuffling. And of course it takes a while. It takes longer than the shuffling, maybe 5 times, 10 times. More shuffles, maybe 50 times, 100 times. It takes a huge amount of effort. So we need to do these things in a more smart way. So let's just use another technique called A-star, for example. A-star algorithm is graph traversal. It's still going on. It is actually, in most cases, not always, it's better than ordinary breadth search because it uses some heuristic about the path. So if the current path is seemingly better than others, it explores first, and from the current position to the goal, it also measures the distance metric it requires. Initial position to the current position, it has some cost function represented as Gn, and current position up to the goal is represented as Hn. If you add Gn plus Hn, it's the current cost, and the next estimate cost, it is cost. So according to the cost, you can prioritize next paths to be explored. Basically, it is sorted out with respect to the cost. If the cost is less than the other ones, such a path with less cost will be explored first. So their queue, definitely it needs queue, but it is priority queue. So if we use priority queue and its cost function with a clever heuristics, then you can accelerate the path finding. So let's make another copy and paste A-star. I'm gonna make A-star. Name A-star solver. Okay, A-star solver is the same, but it used different queue, which is priority queue. And then you wanna make A-star in a main function. It does not use not just ordinary queue, it uses priority queue. And priority queue here has some cost function to sort out an element in the queue. When you get the element with the least cost will be selected and popped out to be explored. So here solution, but it has some initial cost you need. So initial cost is cost plus current least, current cost plus estimate future cost. This is cost is current cost plus future cost. It is the key. So wrapped around using the bracket, you need a tuple. So key and value. Key and value. Value is a solution string, and the key is some cost. So cost here. And then I need to define the current cost and future cost. And current cost could be length of solution up to now, which is 0, right? And the future cost is something like number of non-matched. So current cost is the length of solution so far. And then future cost should be number of non-matched tiles. So it is easily calculated. So future cost, simply Perpinum list. It already shuffled, right? It's list of cloned list of num list, which is already shuffled. And we just check unmatched tiles. It returns a number of matched tiles. So it needs to, we find out unmatched tiles. So m times n minus num tiles in place function should be the future cost, right? We don't need the last tiles, so we just additionally -1 here. So we just copy these things. Whenever before putting the pass here, we just update the cost. Tuple cost and next pass is put in the priority queue. And then if the pass is valid, then the current cost and the future cost and also cost is evaluated, it is put as a form of tuple. Whenever you get some element from the priority queue, the solution is some path with the least cost is selected and popped up. So according to this order, the path is explored. So it's a slightly more advanced one. Let's try it out. Python a*solver and 3x3 and what about 30 times shuffle and try it again. So it is not the tuple, it is only the first element, not zeroth. Zeroth is the key cost. Try this once again and it automatically solves the right solution here. Yeah, pretty fast. What was the BFS solver? For the debugging purpose, let's include number of tries. Number of try is just 0. So number of try increase by 1. If number of try is doubles of 10,000, then just print out number of tries. And then try that. Definitely takes some time, right? But this a*solver very quickly it yields the solution, right? And what about trying 6 times 6 and 50? And what about Python solver BFS 6 50 times? And it takes easily, I need to wait. What about this? It's simply yields the solution is optimal actually. So it's quickly done. Yes. What about another one? Trying out. Yeah, it found out. Its solution is 1, 2, 3, 4, 5, 6, 7. What about that? Less is larger than 20 length. So BFS is one by one exhaustively search for every substring, and if there is no same length of solution anymore in the queue, then it starts with the next one. So it takes a huge amount of time. But compared to this BFS and A*stars, is find out some which seems to be better than the other siblings. Most of the times it yields very quickly the solution compared to it's still going on the BFS, but A* is quickly find out the solution. Hopefully you got the idea of the brute force version of pathfinding and A* pathfinding differences. Thank you guys, and see you next time.